This is a video for MEI Core Pure Mathematics, Calculus 5, Volumes of Revolution and Mean of a Function, 5.3, Calculating a Volume of Revolution with Rotation about the y-axis. Let's have a look at this diagram. We've got here a region that has been rotated about the y-axis. It's the region that's enclosed by y equals fx and two limits, c and d. Again, let's look at this disk here. This radius for this disk is going to be x, and the thickness of the disk is going to be delta y. So if we think about that disk, it has a volume, let's call that delta v, which is going to be pi x squared, the area of the circle, times the thickness, delta y. And so, as before, the total volume is going to be the infinite sum, so the limit as delta y tends to 0, of the sum of all the possible disks of that type. And so that's going to be equal to the integral between c and d, going to be pi lots of x squared dy. Now notice that the integration is with respect to y rather than with respect to x, and this is an x squared in here. Our previous one with rotation about the x-axis had y squared dx, and all that's happened is we've just switched the two over. That's that working tidied up for you just so you can read it more easily. There's the volume of the element, the disk, and there's the integral for the whole thing. Okay, here's an example then. We've got this function, y is equal to 2x to the 0.5, 2 root x if you prefer, and we're looking at limits of 2 and 4. And that's going to be rotated around this axis to form the volume. And we want to find that volume. Well, we know that the volume is equal to pi, the integral between 2 and 4 of x squared dy. And this time round, I want to substitute for x squared to get an expression involving y. Well, I know that y is equal to 2x to the 0.5, which gives me that x is equal to y squared over 4. So if I plug that into here, I'm going to get that the volume is pi times the integral between 2 and 4 of y to the power 4 over 16 dy. Taking out the 16, I'm going to get a pi over 16 times y to the 5 over 5 between 2 and 4. So my volume is going to be pi over 80 times 4 to the 5 minus 2 to the 5, and that works out to be 62 pi by 5. And again, there's that worked through for you so you can read it a bit more easily. And there's my final result. Okay, let's think about these. I've got the region bounded by the curve y is equal to x squared minus 3, and the y-axis and the lines y equals 4 and y equals 5. Which of these is correct? Well, the first thing to notice is they all contain limits of 4 and 5, so they've all picked up the limits correctly. But remember, we want pi the integral x squared dy. So let's see what's happened here. Well, this looks like we've got y squared dx. So that looks like we've used the wrong version. We've used the version that's rotated about x rather than about y. So this one feels like it's wrong. This one, well, I want x squared dy. Now, if you go back up to here, x squared is going to be y plus 3. So that looks correct. And it's dy, and there's the pi. So I think that's the correct one. So what's happened with these two? Well, this one looks very like that, but it's missing the pi. And this one looks like that, but it's got dx instead of dy. All of these errors are common errors. So just think carefully about them and make sure you use x squared dy if you're rotating about the y-axis. There's those tidied up so that you can read them and remember them. So use the formula for the x-axis rotation. This one is the correct one. And these also have very common mistakes. The next video in the sequence is 5.4, mean of a function.